This is a video tutorial on how to solve quadratic equations. It's a part two. The first video previous to this dealt with more simple quadratic equations where mainly the only difference was the coefficient of the t-squared expression was 1. So we could go straight into a factorizing procedure in the previous video. So if this is your first exposure to quadratic equations, I would advise getting used to the ones that I showed in the previous video before going into this quadratic equation where the example has a coefficient greater than 1. Okay, so in the top right hand corner I've written out the general form for a quadratic equation. The general form is you have an ax squared where the a is the coefficient of the x squared expression. You have a plus bx where the b is the coefficient of the x to the power 1 expression, and then you have a constant c. Now, of course, the general form here is written in x, but the actual variable can be anything. So in our example, our variable is t, but the same general order stands. Okay, so what we're going to do to solve these quadratic equations, it's more of you kind of have to learn the procedure of what the different steps you need to do. So there's a few different methods online. This is the way I learned it, and I find it most useful. Other people would have other methods that are more useful to them. So I'm just going to go through the one that I was exposed to. So step one is you're going to multiply the coefficient of the squared expression with the constant. All right. So the first step is we'll do them in order. So we have a 2, and that's going to be multiplied by minus 9. So the 2 is the coefficient here, and then minus 9 is the constant. Now don't forget the minus 9 if it's included here. That's going to equal to minus 18. Now the next step, so that's step 1. Okay, I'll just put a little 1 over here. So that's step 1. Step number 2 is you have to find the factors of this number that when added together or summed in a certain way equal the coefficient of the expression with a single powered variable. Okay, so I'll say that again. The factors of this result, when added together, have to equal the coefficient of the minus 3t here. All right, so what we'll do is over here we'll write down 18, and let's find the factors of 18. All right, so the first one is going to be plus or minus 1 plus or minus 18. So essentially this could be a plus or minus 1 plus or minus 18. The 1 and the 18 are factors. And then the other one we could have is a 3 and a 6, as 3 by 6 is 18. And then another one that we could have is 2 and 9. So from looking at the factors here of 18, what we have to do is we have to see if we can get a value of minus 3 from adding or subtracting one set of these factors here. So the next step is finding them sets of factors. Now I can see if with factors 3 and 6, I know that I can make a value of minus 3, whereas with the other two sets, I can't add or subtract them to get a value of minus 3. So I know that the set or the group of factors I'm looking for are the 6 and the 3. Okay, so how do I get a minus 3 with a 6 and a 3? Well, I know if I have a positive 3 and a negative 6, that's going to equal minus 3. And that's exactly what we want here. Okay, so that's the second step, which is the factorizing part of the procedure. So we have step 3 now. So what we have done so far is we basically set up the information that we need in order to refactor this equation. And by refactoring the equation, we'll then be able to solve for the variable t. So how we do that is, you can see that this minus 3t, so basically 3t minus 6t is equal to minus 3t. Okay, so this is the expression that exists here. But we just found out that we can form this expression in a different way. We can form it with a 3t minus 6t because they're the same thing. So knowing that, we're going to rewrite the original quadratic. We're going to have a 2t squared. Now instead of writing a minus 3t, we're going to write this, but it's the same thing. So I'm actually going to put the 6 first for reasons you'll see. So minus 6t, and then we have a plus 3t, and then we can't forget our minus 9, and then the equal to 0. So try to think that this equation is the exact same as the original equation. It's just that we have replaced the minus 3t expression with an equivalent expression, just more drawn out. So this part of the new factorized quadratic is that part of the original quadratic. So it's the same thing, just slightly opened up. So we've basically picked up the original quadratic, kind of bended it in such a way that we can solve for the variable t. Okay, so the next step, step 4, is going to be grouping the different expressions within this new equation. So we're going to group the first two terms. So we're going to have a 2t squared, we have a minus 6t, then we have a plus, and then we have a 3t minus 9 equals 0. Alright, so now we have grouped these two expressions together. We have a 2t squared minus 6t. Now within that, you should be able to look at this expression and see if there's any common values that we can take out of the expression, of the grouping. So I can see that I can take out a 2t because it's common to both expressions. There's a 2t in here and there's a 2t in here. So I'm going to just take 2t out, and what's going to be left here is just a t, and then what's going to be left here is going to be a minus 3. And how to verify that is just multiplying it back in. So 2t by t will give me back the 2t squared, and a 2t by minus 3 will give me back the minus 6t. Alright, and I'm going to do the same thing for this second grouping. I'm going to take out a common value, and I can see the only common value here is a 3. So I'm going to take out 3, and that will leave a t minus 3. So as 3 by t is 3t, 3 by minus 3 is minus 9, and then we have our equals to 0. So we can see here that there's a t minus 3 that's common to both groupings. So what we can do is we can take that out and we let it equal to 0. So we have a t minus 3 equals 0, but then we also have the coefficients of each grouping we need to set equal to 0 as well. So that's the 2t plus 3. 2t plus 3 equals 0. And then it's just following the algebra. So we have a t minus 3 equals 0. We add 3 to both sides. We're going to get a t equals 3. And this side we're going to have a 2t, and that's going to be equal to minus 2t is equal to minus 3. And then we're going to divide by 2. T is going to be equal to minus 3 over 2. So these are our two values for t that satisfy the above quadratic. And so to verify, you could plug in the value t, and you would see that when the value is plugged back in and you work through, it will be equal to 0. So the equation will be balanced. So that's the procedure to find a quadratic equation with a coefficient greater than 1. It's a lot more simple when you just have the coefficient equal to 1, as you can see in the previous video. But I hope you enjoyed that. Hope you learned something. If you enjoyed it, if you're enjoying the algebra, I'm going to do a whole course on it. It's a new channel, so a like and a subscribe would be greatly appreciated. And you know, even any comments in the comment section would be, I'll definitely respond to them. So yeah, hope you enjoyed, and we'll see you in the next video.